So this is the input shaft. I wanted to show some of the things that we discovered when we did the inspection. This is the end of the shaft that fits into the clutch plate. So this is what is usually lubed very frequently with moly paste to prevent rust and damage. And in inspecting the splines, they all look to be uniform, no cracks or chips or breaks, and really no rust. So I think these are in good shape. Next, this is the inner race for the roller bearing that the shaft fits into in the front of the transmission. But right in here there's a score in the race, which is created by the input seal. I'm going to be replacing all the bearings, so I'll get a new inner race. So that shouldn't be a big issue. The other thing I wanted to show is that this is this torsional shock absorption system, so that when this shaft is spinning and there's a sudden mismatch in speed from the output shaft through these helical gears to the input shaft, this actually slips, which prevents a big shock load going into the gear teeth so they don't break off or chip. So if this has been abused, you'll find cracking or chips or pieces of material missing off these two pieces, but they're in good condition, so this particular shock coupling hasn't been slammed around real hard. Now the helical gear teeth, and you can see that a little bit right here, there's a score in the face of the tooth, so there's some wear there, and on this tooth there's some more pitting and wear. It's not every tooth. There's about 3 or 4 that show that pattern, and the others appear to be fairly good condition. This one is another small score. So I'm going to try to find a used gear, if I can, to replace that, and then I'll disassemble the shaft anyhow to replace this inner bearing race, so I can get to this gear and replace it if that's what we decide to do.